It is time to start focusing on more complicated algebra. Today, we're going to start working with polynomials. Now, polynomials really look at the terms of an expression. So if we have a monomial, the prefix mono means one. It means we have one term. So x could be a term, 3 could be a term, 3x squared is a term. Notice there are no addition or subtraction signs. A binomial, bi means two, means we have two terms. So we have two unlike terms that are put together in an expression using addition or subtraction. So x plus 3 is a binomial, a minus 4 is a binomial. Now trinomial simply means three. So we have three unlike terms that are put together using addition or subtraction. So x plus y minus 5 would be an example of a trinomial. And these are all expressions. So when we go to the term polynomial, poly means more than one. Poly is a lot. It just means it encompasses any of these. A monomial, a binomial, a trinomial are all considered polynomials. And our polynomial can go bigger than just three terms. So we could have an infinite number of terms if we wanted, separated by addition or subtraction signs, and those would be polynomials. So don't let the big terms scare you. It's actually kind of an easy concept. Now, not everything in math is a polynomial. There are three rules we have to follow. So, rule number one, you cannot have negative exponents. So that would not be a part of a polynomial. Rule number two, you cannot have the variable down underneath the division sign. So in the bottom, that would not be a polynomial. And rule number three, you cannot have the variable inside the radical sign. So those three things would cancel out polynomials, but anything else would create the polynomial. So 4x squared would just be a monomial, which is considered a polynomial. So here's a big concept for today. It's this concept of degree of terms. Now terms, remember, are those things that are separated by the addition and subtraction sign. So we're looking at those individual pieces separated by them. So here I have this expression. When I take a look at that, in order to get my degree of terms, I'm simply looking at the exponents. Now negative 2x cubed y is a single term. So I take that as all of it together as one, and I look at the exponents and I add them together to get my degree of terms. So I have an exponent of 3 and I have an exponent of 1, therefore my degree of term for that term would be 4. Now I go to the second term, I start all over again because it's the degree of each individual term. So this is pretty simple to see because it has a single exponent of x squared, so that degree of term would be 2. 3x, it doesn't seem like it has an exponent, but remember we can always put a 1 there. I have one of those x's. We just don't usually put that as an exponent, but that degree of term would be 1. And then if I have a constant, I have no exponent with it. Constant's degree of terms are 0. So when we're looking at degree of terms, we're only looking at the value of the exponents. Now, why are we looking at that? Well, number one, when we are gathering our like terms in these polynomials, you only gather the like degree of terms. So I could not put my degree of term 4 and my degree of term 2 together. They are not the same degrees. So it helps us gather our like terms. The second way this helps us is we always have to write our final answers going from largest degree of term down to smallest. And remember, we're going into complicated algebra now, so we're going to have a lot of terms. So we have to follow those rules. That's what everybody does. So let's watch how degree of terms helps me gather my like terms. So we're going to combine like terms. Now don't forget anything you've learned up to this point. If I see subtraction to help me gather those terms and see those integer signs, I'm still going to change it to plus the opposite. And I still look for distributive property. And I can see right there I have distributive property. So I have to do that first. So everything you've learned up to this point, don't forget, we always apply it. So my first step here is I would rewrite this expression, changing all this subtraction to plus the opposite. Once I've done that, then I know I have to do my distributive property first. So I'm going to start right here, and I'm going to do negative 8 times 2y squared plus negative 8 times 7. And I'm going to finish that off before I go to gather my like terms. So a negative times a positive is a negative. 8 times 2 is 16, and I just bring the y squared with it. And I have negative times a positive is a negative. 8 times 7 is 56. Now I add in the rest of the terms that I didn't work with. Now we're going to go back to this concept of degree of terms. I can only gather together what has the same degree of terms. So when I look here, that's y squared. That's different than y, because this has a degree of 2, this has a degree of 1. Now this has a degree of 2, so I can add these two together. Lots of kids think if they just see y, then they're just going to put all the y's together. You can't do that. Only the y's that have the same degree of term. So I'm going to do my negative 3y squared plus my negative 16y squared. I'm going to pull those together to combine them. So when I pull those together, they're both negative, so I get negative 19y squared. So I'm done gathering those terms. Now I have my negative y, and there's nothing else I can put that negative y with because it has its own degree of term of 1. So I just leave it as negative y. And then negative 56 has a degree of term of 0. There's no other degree of terms of 0 there, so I can't pull that together with anything else. So now my final step is I'm going to change my plus the opposite back to subtraction of the positive. So I get negative 19y squared minus y minus 56, and I check those degrees of terms just to make sure that I go from largest degree of term to smallest degree of term, and I know that I've written it correctly. So that's how we're using degree of terms to combine our like terms. Now sometimes they're just going to say evaluate the polynomial. Well, remember, these are all expressions, they're not equations. So in order for me to evaluate it, I have to know what the variable is. But if I know the variable, all I have to do is substitute the variable in for every x that I see. So when I see that 4, I substitute it in. Now I have to follow order of operations. So if I see 2 times 4 squared, I got to do the squared first. So 4 squared is 16, and I only do one operation per line. Then I do 2 times 16 is 32 because I'm going to work from left to right. Then I do 32 plus 4, which is 36. 36 minus 7 is 29. So notice I never used an equal sign in it because I was evaluating that expression. So you can see how everything we've learned as a base is going to help us do this more complicated algebra. Today, polynomials. Do not get frightened by the length of it. You're going to do really well with this. Just use what you know. Good luck.